with respect to x. What did you get? fx negative 1/3. How'd you get that? So it's this point right here, right there? Oh, you can't see it? Okay. How did you guys get negative 1/3? Someone who wants to explain it to me? Who wants to explain it to me? Molly, yeah. How'd you get that?
So y is fixed at 2.
Yeah.
2 minus 1.
So 2 minus 1, yep.
Oh, wait.
2 minus 1?
No, I did 0 minus 1.
0, exactly. 0 minus 1 over what? Over 6 minus 3. Correct. Nice. So that's going from this point to that point, right? So if you wanted to do fy, let's do that. So fy 3, 2, what are you fixing?
X.
You're fixing x, so you're fixing it across like that. So what's that going to be? 2 minus,
1
yep.
over
5 minus 2, right? Yeah. So 1 over 3. So one's 1, negative 1/3, one's 1/3. Does that kind of make sense? Nice. Okay. Excellent. Fantastic. Very, very.
Negative 0.049.
I got it. Negative 0.049.
Mm-hmm.
Anybody agree with that?
Yes.
Yes. And anybody get delta x is 0.001 or 0.01? Anybody have that one?
Negative 0.052.
Do you hope that they're generally close-ish together? You hope so, right? Numbers right here are just what, though, so far? What are these?
Estimates.
They're just estimates. Now, could you use the limit definition? Could you use the limit definition? Sure. If you wanted fx, xy, again, is that x or y is fixed? What is that?
Y is fixed.
That's y is fixed. So that's going to be the limit as h goes to 0 of what? F of
Plus h,
comma y minus f of a, b, yeah, x, y, sure. Yeah, we'll keep it as a function all over what? H. Now, you could run a limit on this. You could run the limit and then, do you remember working on limit definition questions?
Yeah.
Yeah, they can be a little nasty sometimes because you can't plug in 0 right now because h is in the denominator. So your whole goal was to get something with h in every piece in the numerator so you could cancel out the h's and move forward. And then you would do a lot of that, and then you would realize, oh wait, eventually get taught some cool derivative rule from your teacher, and then kind of like your teacher more, and then hate them because they made you do all those limits. Okay, let's look at this logically, though. Let's look at this logically. You just said, can someone just say again what this means? What does this mean right here? What's changing and what's staying the same?
X changes.
X changes, but y stays what?
Constant.
The same. X changes, but y stays the same. So on this one right here, what's different about this question right here? It says find it what? Algebraically. It says find it algebraically, meaning we're not picking a delta x. So could we come up with an estimate for an answer for this?
Yes.
Do that for me right now. I'm going to let you free-form choose use a calculator. Estimate that for me. Estimate that for me to whatever degree accuracy you want. Try it. Use your calculator.
Okay.
There's an interesting piece missing there. If I keep this constant, what's the only thing that's changing? X. The only thing that's changing is what? X. The only thing that's changing is X. Oh, nice. So if X is changing, yes, team? Excuse me, it is X squared y plus 1 to the negative 1 first, right? Do you agree with that? So if I were to just move X, meaning y stays the same, this is the only thing you're taking the derivative of, right? What's the derivative of X squared? 2x. But y is constant, so does it just go along for the ride? Yes, this is just along for the ride. Oh, wait. So if this is the algebraic derivative of f with respect to x, what point did we want to do it at? What was it, 3, 2?
Yes.
You plug in 3 for what?
X.
3 for x, and what do you plug in for y? 2, and what do you end up with? 6 times 3 over 3 to the negative 1, which is 2. It's really ridiculously simple in application as long as you keep the right things constant and take the derivative of the rest. The easiest way to mess these up by far is to flip it or do like a product rule or like make something up. It's much easier than it looks in practice as long as you are practicing the right differentiation. So what about here? If you do this one right here, what is constant now? X is constant. So if x is constant on this, what are you just taking the derivative of? Y plus 1 to the negative 1. What's that going to be? Oh, well, this stays the same, right? Oh, wait. Sorry, the x squared stays the same. When you take the derivative, what happens to that negative 1?
It gets carried down
To the front. And then the negative 1 becomes a negative 2, and then the chain rule just kicks out a 1, right? That's why it's invisible. So if you want to evaluate the derivative at 3, 2, you just plug in 3 for x, and what do you plug in for y? 2. Oh, look, it's just negative 1. Algebraically, is that pretty simple?
Yeah.
The key is making sure you keep the right thing constant. I can guarantee, and I'm saying it's okay, you're going to make mistakes. You're going to, oh, x changes, the y, and then just go with it.